So I had a couple people reach out about data. So I think if you can get, how many of you are able to get to this interface? Seeing almost everybody. Who's not? Everyone's gotten this far. So there's been some time. So usually I think the way I walk through it is you go down, you can just open up data. If that's still giving you issues, one additional thing, and I relabeled the original video on YouTube. So I didn't walk through it in class because I didn't think you still needed to do it, but it must be some kind of like a certain systems or certain software, like Mac versus PC. You still have to do this additional step, which is go up here to this like little settings, account settings, and make sure you're activating Citrix Workspace app. So just click that. You can, I don't even think you have to run this. Yeah, so it just downloads it. And now when you go back to apps, that should fix most people's issue if you're having it there. So making sure you did the additional step, activate it there. You did everything else that we walked through on Tuesday. That should help a lot of those of you who are still having issues. How many people were able to actually get the program open? So pretty good chunk, right? How many not? Couple. Yeah. So you can talk to me after class. Like I said, if that doesn't work, hitting that activate, it might be a setting on your computer that we have to find that it's not, giving Citrix access to certain things that it needs access to. Okay. Now, I'm not going to have I'm not posting an assignment right away. There will be one next week that you'll have to start kind of working on using Stata. So if you don't have it completely working yet, it's not the end of the world, but we do want to try to get that resolved if you are having issues as quick as possible. Any other questions for me before we get going? There was one other thing I wanted to mention, and I think we caught it, but I updated the slides and the syllabus. I forgot that I agreed to teach an additional, because I think there's like 35 people on the wait list for this class, and I agreed to teach an additional section this semester. So usually the numbering coincides with the time of class, but because it was added late, the section number is actually, the higher section number is actually my earlier section, so I accidentally flip-flopped the two. I probably won't be the last time I call you by the wrong one, because it's just so ingrained in my brain, because that's how my classes usually, or my courses usually are. But I've got everything updated now on Canvas, so it has the correct final exam date and time on there. Okay, so take another look at that, make sure there's no conflicts there, because it was slightly different from the original one I had posted. Okay. All right. There's no questions. Kind of dive into things here today. So we're still going to be doing, I think, review of a lot of concepts you should have seen in 370 or the equivalent, whatever your equivalent was. So we talked. See if it likes this. So we talked about the mean, which is kind of often sometimes referred to as the first moment of the data, right? It kind of is the first descriptive statistic that we'll look at. The second moment is going to be what we call the variance, right? So what we're doing with the variance is we're going to kind of review this. So lowercase sigma now squared is going to represent our population variance. Once again, Greek lettering is going to be what represents population statistics, okay? So sigma squared is our variance. What we're going to do is we're going to go through every single observation and add up whatever this expression on the right-hand side of our summation sign is. Okay? So we're going to start with the very first observation, subtract the mean, right? So in order to calculate the variance, we have to first calculate the mean. We take that, what we call deviation from the mean. I'll use this phrase a lot. It's just the difference between that X or that Y value and the mean of that Y variable. We'll square that deviation from the mean and then kind of average it out, right? Divide by the total number of observations. So every single observation is going to have some evidence that there is variation in the data, right? Not every value is exactly the same. We want to know kind of this isn't a perfect description of the variance, but it's kind of like a average variation from the mean in our data set, right? Now, the reason why that's not a perfect explanation of what the variance is, it's okay to kind of think about it that way, is because when we square things, so if I were to not square it, right, 1 to 2, I'm adding, the difference is 1, I just add 1 to 2 to 3, the additional value of 1, just adding 1 more. But when I square those values, 1 squared is still 1 that gets added in there, but now 2 squared is 4, so I'm getting 3 more in there. 3 squared is 9, so 6 more. So as we get further and further deviations from the mean, by squaring that deviation, we're really over penalizing like extremely large outliers, things that are very far from the mean. Okay, so our variance kind of over penalizes these really, really big deviations from the mean. We can also calculate the variance of a discrete random variable. It's going to be very similar. It's just that we take the different outcomes for y, we subtract the mean, square what that deviation from the mean would be. That part's kind of the same. We then multiply it by the probability that we saw y take on that specific value. Now, I mentioned this last class with the mean of a discrete random variable. Really, n is floating around behind the scenes because in order to calculate probabilities, let's say maybe I want to know what's the probability that you get an A in this class, and there's like 10 out of 40 people got an A. Well, what did I do? 10 over 40 to get my probability. I was dividing by the number of people in the class or my population, right? So really, this probability kind of baked into it has that dividing by the population size, okay? We can also scale the variance, right? We'll use this a lot as the standard deviation. It's just the square root of the variance, right? So we can go back and forth in between these very easily. The standard deviation has a little bit more usefulness to us and some other things that we're going to do, but it's really just scaling that variance, okay? So I've got a basic example here, and this is where, yes, I'm recording these. You know, you can always kind of go back, and especially for like the status stuff, maybe it's helpful to kind of go back and see what examples we did in class, especially if you're still kind of having issues kind of getting that open. But whenever I go to the dot cam, that stuff does not get recorded. Okay, so for here, let's think about if I'm wanting to think about the mean and the variance of this random variable, how would I calculate this? Right, so it's a discrete random variable. I had a bunch of different values, right? And you can kind of see them if you saw the slides pull open, but it was 0 through 12. And the probability of seeing y be all those different values. So the very first thing I maybe would want to do is calculate the mean, which I know is going to be the sum of all the different y values times the probability. I shouldn't have put the extra parenthesis in there, but y is equal to that specific x value, right? So I'm going to go through, or sorry, yeah. I just didn't write it very clearly. So what I'm going to go through and do is, okay, what's the very first value that y could be? 0. If I look at that table, the probability that y was 0 was 0. I really could have ignored that one, right? It's just going to add 0. But the second possible y value would have been 1. What was the probability I see it be equal to 1? I think it was, I'm going to try to do this from memory. There we go, 0.06, right? Okay, good. I wasn't sure what the numbers are. The next possible y value is 2 times the probability we saw 2 was 0.03 plus 3 times the probability we saw 3, et cetera, right? All the way to the very last possible y value of 12, and the probability we saw that y value of 12 was 0. Right? So hopefully this is kind of looking like something you've done before in a previous class. You know, doing this by hand isn't very much fun. You can do it in Excel pretty quickly. In fact, in order to calculate my variance, I would need to find, right, what? The sum of the deviation. Technically, I probably should have written notation-wise. The mean of y squared times the probability y takes on that specific y value, right? I need to first calculate my mean. I can't do this math in my head, so I can go open up Excel. I'm not necessarily going to expect you guys to do this. I'm just doing this so I can actually get the actual value here, because I don't have a calculator right here in front of me. Oh, there we go. So I'm just going to copy, paste. Oh, there we go. Roll this up so we can see it. So if I want to calculate the mean, I'm going through, taking each y value, multiplying that by the probability y takes on that y value. Right? So for every single observation, I'm going to take the y value, I'm going to multiply it by the probability. This is what we had written out. I'm then going to do that for every single observation. Then to get my mean, I just add all those up. Okay. So this kind of shows, programs with Neurium can do things that's going to take us a lot of time by hand and do it pretty quickly, right? I'll show you how we can do it even quicker later on today and save it, right? It literally just spits it out at us, right? We click on like 2 buttons and it spits it out. So here I've got my mean, right? I then want to calculate my variance. I know that I'm going to need the deviation from the mean squared times the probability that y is equal to that specific y value, okay? And here I can make these a little bit bigger, right? So I'm going to go through and say, okay, look, take this y value, subtract the mean, square that deviation from the mean, and then multiply it by the probability I saw y take on that specific y value. Now, when I drag this down, it's going to update all my cell references. I don't know if you were in 370, how much they incorporated Excel. I incorporated every single section or every single topic, module, whatever you want to call it, that I do. Like I said, we're not going to use Excel a ton, so it's okay if you don't have that background from your 370 course. But we need to freeze cell references when we copy this down. Otherwise, it's going to try to like update this to be blank. And we always want to subtract the same value of 5.12. Right? So copy this down. Add them all up. We get about 5.4 of our variance. What if I wanted the standard deviation? What's the only thing I have to do? Yeah, and I've got built-in square root functions I can use. I can get the standard deviation pretty quickly as well. Right? But we're thinking about how would we write this out, just to kind of be a little bit complete here. In our example, it would have been, okay, the very first value was 0. We wanted to subtract that mean of 5.12. Square that value, and the probability saw 0 was 0. So that one's not overly interesting. Then add in what's the next possible y value, 1, subtract the mean, square it, multiply it by the probability we saw the value of 1. Add to that the next y value of 2, subtract the mean, square it, times the probability we saw 2, all the way to the very last possible value for y. Okay. But you can kind of see in Excel, makes our life a lot easier. And we'll also see Stata can do a lot of this behind the scenes and do it pretty quickly for us as well. Okay. Hopefully this is looking like a little bit review. Any questions on this before we keep moving here? Good with this? Kind of boring. It's so easy, right? We went through. So I'll do this a lot of the time. I'll leave like a blank slide open if I'm going to do something in the doc cam. So this was kind of what we just went through mean and variance example. There's also different measures, and I'll kind of briefly discuss them. We're not going to talk too much about the calculations of them, but we kind of think about the variance was our second moment. We can look at the third and the fourth moment as well. So this third moment is going to be some measure of how skewed our distribution is. Okay, so it's out of here. We kind of think about, you probably in the 370 or whatever, talk about like a normal distribution or something that's symmetric, right? Each, what we would call tail, is exactly the same. Something like income, like the vast majority of people make in between like $0 and $100,000, right? Like that's like 90% of people. There are also people who make more than that, right? But not many. And then there's some like uber rich people, Elon Musk, all those, that really pull that right tail of the distribution way out. But you can only make 0, right? You can't make negative. Right? I can't think of a way where you could, like, you're paying someone to work for them. I guess maybe you could look at if you're like working for donating your time. Maybe that's kind of like a negative salary. But you get my point, right? You're kind of censored on that left tail where that right tail gets pulled out really far. That's what we call kind of this right or positive skew distribution. Like I said, it's an easy way to remember. Long right tail skew. You might also have examples like this, and I was trying to think of one in my previous section. I think this one's pretty good. It also kind of gets us some economic questions we can kind of think about. Kind of interesting. We'll be able to tackle later on in the semester. So what if I'm thinking about, I had the distribution of, let's say I had a data set of every single person that died from the flu and I had their age, right? Well, this isn't a perfect example, but let's say I only was looking at people who were age 5 and above, okay? Most people that die from the flu are old, right? So when I'm looking at flu deaths, I'm not going to see a lot of people at 10, 15, 20 dying from the flu. In fact, how many of you have gotten the flu vaccine? Handful of you. It's probably not a bad idea, right? But I just lazy. I don't know. I'm lazy. I don't really care. My immune system's fairly good. I'm not that concerned of getting the flu. I don't think I'm going to die if I get it. It's not going to be fun, but I'm not going to die, right? If I was 85, you better believe I probably have the flu vaccine right now, because if I didn't get it, that's probably the last flu I might ever have, right? So when we look at things like the flu vaccine, we're going to talk a little bit later about like correlations. There's always going to be, we want to think about like selection issues, right? So it's going to look like in the data that the vaccines are causing people to die from the flu, but like obviously a selection of who's getting those vaccines, right? But it's also these flu deaths. It's a really good example of something that we might see kind of this left or negative skew, because we've got this long left tail. Most of the people dying from the flu are going to be kind of those older age ranges. Okay. But you can kind of see we're kind of looking at here like deviations from the mean to the third power. That's going to be how we measure the skewness. I can get this going. Here we go. And then we have kurtosis, which is our fourth moment, which is just going to tell us something about how fat our tails are, right? Even if we have 3 symmetrical distributions, right? Maybe we have our perfect kind of standard normal distribution. We might have a normal distribution, it's symmetric, but it's like squished down more, where we kind of have negative kurtosis or fatter tails, right? We have kind of this higher peaked distribution, we call that positive kurtosis, or we have like very, very small tails, right? Or thin tails, I guess if you want to say it that way. We won't use this a ton. We're just kind of walking through some statistics that we're actually going to get from Stata here in just a little bit. Okay? We're never going to have to worry about calculating these by hand. We also might be concerned about 2 random variables, not just one, right? So what are some statistics that you remember that measure the relationship between 2 variables? Or anything?
Correlation.
Yeah, I would say, people in haven't taken stats courses know about like correlation. Like people talk about these things, they're correlated, right? Or what do you need to find the correlation coefficient? Anyone remember? Covariance, right? We actually can't calculate the correlation coefficient or correlation without the covariance, and I'll show you why here in a second. So let's say I have this example, because I've got this data set where I've got the class size, like a elementary school class size, and then how that class performed on this standardized math test, right? Or you can think about maybe I have individual student data and what the size of their class was and what their math score performance was on this standardized test. What I would do to calculate this covariance is walk through every single observation. Say, okay, look, here's this first kid. What was the deviation of his class size, his or her class size from the average, from the mean? I would then take that and multiply it by what was that student's math score minus the average math score. I'd multiply those 2 deviations from each of those variables means. And if they're both negative, negative times negative is positive, right? Well, if they were both negative, that would mean that when class size was low, so did the math score tend to be low. That was one observation that these things are positively correlated, right? They tend to be on the same side of the mean. What if the deviation from class size was negative, but test score was positive? Well, that would be an observation where I'd have a negative value added to my covariance, because there it was telling me that these variables tend to be on opposite sides of the mean, right? When class size was low, test score was high. Right? And then you can go through the other combinations, right? Above average class size, math score was low. Once again, evidence that these things are on 2 different sides of the mean. Okay? So we would do this for every single observation and then add them all up. Right? That's going to tell us essentially, you can kind of think about it across every single observation. Do these 2 variables tend to be on the same side of the mean or on different sides of the mean? Okay. So if they're tend to be on the same side, we're going to get a positive covariance. If they tend to be on different sides, we're going to get a negative covariance. Now, the problem with these covariances are, what are my units here? If I multiply class size by math scores, I've got like, what? Student points or student, however you're measuring the, whatever you want to call on a test, right? Points or whatever it is. Well, student points doesn't make a whole lot of sense. It also kind of prevents us from making comparisons, right? maybe we find some type of a covariance between math scores and class size, but maybe I want to compare it to the covariance between hours studied and performance on E371 exam, right? I can't really compare those because then I would have what? Hour points, well, student points, hour, my units, I can't compare across these different relationships because they've got these goofy units, right? So how can I make this a nice unitless measure and also account for the fact that some variables have different variation in them? So I'm going to tend to see more things be on different sides of the mean. I can scale my covariance by dividing by the standard deviation of each variable. So now you think about here, I had student points divided by students times points. Oh, all my units cancel, right? So our correlation is essentially going to be us scaling our covariance so that we get it to be between 1 and -1, and it's unitless. Now I can compare and contrast and say, if I find a correlation between two variables of 0.5, that's evidence of a stronger relationship than a correlation of just 0.1. And I could say that a correlation of -0.9 is a stronger negative relationship than that positive 0.5. So I can start to compare and contrast across these different types of, different variables and different types of relationships. And you can kind of, I'm not going to walk through like the mathematical proof, you could probably Google it, but you can kind of think about why it's becoming between 1 and -1, because we've got like a deviation in this X variable, and I divide by the standard deviation. Remember, in my variance, it was like the deviation squared, but then I was taking the square root, so that kind of canceled, so this is kind of it's not perfect explanation exactly what's happening with the math, but you kind of envision why like these things are kind of canceling out to where we're getting something that's either going to be between 1 and -1, right? Once again, if you're interested in that side of it, Google the mathematical proof of correlation coefficient, and I'm sure you can find a step-by-step line of it. Okay. Any questions? I feel like I'm doing a lot of talking. So any questions before we keep moving? Hopefully it's kind of looking like review. I'll do this in state. I just wanted to kind of remind myself. So one more thing before we kind of hop over is if we have these two relationships, instead we can also create these scatter plots. So you hopefully talked about these before. Here I just took the class size math scores. So this comes from the same data set I showed you on Tuesday, the ISTEP data that I grabbed from the state. But you can plot like every single one of the observations. I took a smaller subset, so there wasn't too many dots up here. But we can do this in Stata and kind of see, oh yeah, it looks like as class size goes up, it kind of looks like we're getting like higher math scores, right? Which is kind of weird. Maybe there's some weird explanation that, yeah, there is a correlation between these two things, but maybe something, the reason why class sizes are larger, maybe it's because those schools have more in-class like aides or something like that. So we don't really know, but here we can at least get a kind of a quick snapshot of what that relationship looks like between these two variables. Okay. So with that in mind, let's go here. So last class, we kind of got to the point where we like just opened up a program, right? So here I'm going to go to open. I've got a do file on my OneDrive. And I think so we are the smaller section. I need to remember this. Oh, I mixed them up. I forgot. I put it in week 2 because we're going to use this again in week 2. But it's up there on Canvas. Somewhere. There we go. It's going to be this review of statistics do file. So this is a bunch of code that I'm going to kind of walk through now and mention a lot of things, kind of how we're starting out in Stata here. So we're opening files last class. I talked about creating global paths. So here I've got this global path set to be my OneDrive because it looks like I changed everything to paths. I originally was doing this from my desktop, and so I was trying to, well, I can't pull things from my personal computer. I was going to pull up my OneDrive, but I want to switch back and forth. So we talked about creating these global paths, right? And you'll see what this is kind of handy later on because I've got all the files in kind of a similar location. So we said here's, you can kind of import delimited. This was the code that imported the file for us, or we could go to import. We're importing this state cigarette tax. It was a CSV file. So I had someone my last class say, I can't get it open. It's saying it's the wrong type. It's not an Excel file. They look very similar, right? But the actual file I gave you is a .csv. Sometimes when the files get too large, we can't use Excel for them, right? So if you do have an Excel file, you can import that as well. It's just that when you're choosing what to import, you have to select the correct, right? Match up with what file you're trying to open. So I go to my OneDrive to that folder for this week one. We're trying to use this state cigarette tax, and I think this is going to be take an annoyingly long amount of times, but we'll hit OK. Oh, maybe not, right? So I can run it there. Now I've got the data open, right? So remember we said there's three things: the actual program where it's running the code and kind of spitting some output out at you, which we'll see here in a second, the actual data itself, and then where you're going to kind of save all of your code that you're running, okay, your do file, okay? So one thing I didn't talk about last class is sometimes, we'll have these variable, like whatever the data comes in. Sometimes maybe we don't like these names. I don't know. This is like the state abbreviation, but it's called, and you can widen these. There we go. Location abbrev and location DESC. Maybe, I don't know, for whatever reason, I don't want to type out as much, or I think it's an easier way for me to remember to call these variables something different, right? So I think in the file that I have posted, because I did this in my actually, I accidentally wrote over that one, didn't I? Let me see. Let me see if I have the original version, because I accidentally made changes when I was working on this for my last section, and I accidentally saved over it. Yeah, I don't have it. So I'll try to remember what I see. So I think this is originally what was in the file, was kind of renaming this just to be state, right? So the way that this comes in handy. You don't have to do this necessarily, but there's a command rename. I just say, okay, here's the variable name that I want to call something else. It was that thing that had the state's abbreviation. And maybe I just wanted to rename that to be state. So I go up here, I execute that line of code. Now, if I go to my browser, oh yeah, now this variable is just called state. Like I said, this is, just little things. I know I'm expecting you've never used this program before, so I'm kind of showing you some of these things that might make your life a little bit easier down the road. Okay. And then I'm also going to rename this location description variable, excuse me, to be state name, right? Just kind of, we can rename things. We can also then, I've changed the data a little bit, right? I've renamed some stuff. Now this is where I've imported this file. Typically, like best practices would be like, once I import it, save it as a Stata file, right? So you don't want to be worrying about importing different files. Once you've got it imported once, you want to just be able to open it up right from Stata. So for instance, if I am in this, if I'm in the program and I go to file open, the only thing that I can open are what we call .dta files. And those are data files that are saved under the program Stata. Well, right now, I have a .dta file kind of pulled up, like the data's in here, but I haven't saved it. It doesn't exist anywhere on my computer yet. So I'm going to go run this line of code that would save it, or show you how I got that line of code. So you can just go to, I have the data set open. I go to File, Save As. I'm going to save it right here. I'm just going to call it state cigarette tax. I'm going to call it 2, just because this is the second section. So I created it already for the first one. So I'm going to hit save. Right? It's going to think for a second. We'll wait. Yeah, spinning wheel. So as we wait for this, so I'm saving this, right? I'm now going to have an additional file, state cigarette tax, but notice it's not a CSV anymore, it's .dta, right? And I called it state sig tax 2, because this is for like the second section. I already created it for the first. So you can kind of see it here. It saved this for me. Now when I go to here, it saved that .dta file, state sig tax 2, okay? Any questions over that before we keep moving here? Good with that? Yeah,
Sorry, I didn't get how you open the state segment data.
yeah, so we
You
had to go
imported
to,
it?
we had to go to file.
Yeah.
You had to import because originally it didn't start out as a .dta file.
Yeah,
When you download it off of Canvas, it was a CSV, right?
okay,
So you would import this CSV. You would go here, select that, hit open, and that should automatically put that line of code that imported that data.
and then you just save it as a DB.
And then I save it as a .d. Then I can go right to the user, the interface here and just go to File, Save, or Save As. Yeah. Okay. Any other questions? Yeah.
How'd you open up the code editor?
Oh, the do file?
Yeah.
Yeah, sorry, I should have, I think I showed you last class, but I probably should have done it again. So just as a reminder, once you open the program, there's two things that I typically always open up before I do anything. I open up my data browser, so it's that little I don't know, grid with a magnifying glass. And then I also open up my well, I accidentally just create another one, but I click on this little notepad and that opens up your do file editor or where you save your code. Okay. They're good questions. Any other questions? Yeah.
How did you execute the thing? How did you execute the function?
This or this?
The location bar one.
Yeah, so so this, you can type code out here.
Yeah.
This is a good point. Okay, so let me go, I'm gonna rename year and just capitalize here just to show you. You can always just type your code out here, and when I hit enter, it'll kind of spit that out at us. Or I can write it here, and when I highlight it, in fact, since I've already done this, it's gonna try to, well, just import it again. Or I can highlight my code instead of typing it down here into the box. I've got it in my do file. I highlight what I want basically to throw into this command bar, and then I hit this little execute selection button. Now because I renamed it something. Oh, I already renamed it here. Because why isn't it like that? Oh, because I didn't define my global, right? There we go. Now I can show you. So I can execute it from the do file, and then it basically puts it in that command box and hits enter for me.
Okay.
Is that what you were
Yeah.
asking? Yeah. So in order, you can't just type it in here, you have to highlight it and then hit execute.
Okay.
Also, as a reminder, I when I was running that before, I wasn't recognizing what I was doing, is because I also have to execute where I'm defining that global path as well. Or I can always just go file and import and always do it kind of manually, or file open if it is a .dta file.
Could you show one more time how you imported this?
Yeah, so you just go to file, import. What type of file was it? It's .csv. We then go to this folder so we can find where the file is. And then wherever you've downloaded the file, you have to go there and click on the actual file. So you can't like download it from Canvas, or sorry, you can't like import it from Canvas. You have to first download it onto your computer and then you can import it. Yeah.
I'm getting an error. It says that the operation has been canceled due to restrictions in effect on this computer. Please contact your system administrator.
Oh, I fixed that. It just takes one more attempt, and once you go to the file manager, it will give you the option to override it.
You have to save.
So hold on. What error are you guys getting? It's saying system.
Administration access required. So once you guys go to the file administration, it will automatically allow you to override it.
Where's file administration?
So once you open the folder, once you open the desktop, and you can see all your files, and once you select the file you want to import, you can just grant it all access and let the program be able to access everything.
Can you guys quiet down for just a second? I think
I can answer.
Yeah.
Basically, for anyone who has HPs, right, I just went through the same problem. I was trying to figure it out in the past 10 minutes. I figured it out. The problem is you need to download it from Canvas as an Excel file, right, as an Excel file, and then in Stata, and you're gonna upload it to the cloud, right? And so now it's in your OneDrive, and then basically what we're gonna do is go into Stata, import it as an Excel file, into Stata.
So it's downloading from Canvas as an Excel file, not a CSV file, is what you're saying?
Well, the thing is like, I couldn't get it to download as a CSV file. And so my other option was like, okay, my computer works with Excel.
Okay,
might as well
So-
do that.
let's do that then. If well, here, I want you guys to be able to work along with me, so I want to try this real quick. So I'm going to save it as an Excel file so that you guys can all open that up. Maybe this doesn't take too long. So I think maybe part of the issue is, or maybe try this if it's not working. It might not like that it's on your desktop, and maybe you should be downloading it to your OneDrive. There's something about, like I said, I think it's something you probably could change some settings, but it's not gonna get I don't think you're gonna have to change anything if you drop it onto your own OneDrive. So for some of you, it might have worked even if you don't do that, but anytime we have these files, you can just download them to your device, but I would make sure you're putting them, create a folder on your OneDrive that's ECON 371, and just out of default, always download these files that I'm putting up, always download them to your OneDrive, and then I think it shouldn't have that grant or system, whatever the error is, okay? Does that help? Does that work for some of you? Is that, okay? So I'll put up the Excel, or I'll do this real quick so you can, even if you're having issues with the .csv file. I'll save a new one here. Same data. We'll go to save as, throw it in here. Call it state, sigtax. Exit out of all this. I don't need this anymore. And real quick. We're going to. Interface is kind of goofy. All right, so it's just floating out there under the files now. It's just so it'd be easier to find. Where is it at? I'll probably move it after class, but state sigtax. This is also a good, I guess, useful that I can also go to file, import, and I don't need to import a CSV file anymore because now it's an Excel file. We're waiting. There you go. Oh. I want to make sure I already had this open, so give me a second. Oh, now I go to file, import this Excel spreadsheet. I'm going to browse. I've got that state cigarette tax now. I'm going to open that up. The only difference when you use an Excel file is you often have to select this box, which is to import the first row as variable names. Otherwise, it just tries to treat it as an additional line of data. So whenever you're importing Excel files, make sure, and I was going to use an Excel file actually next week for an example that we're doing. But here you always have to make sure that this box is selected. Okay. Now, once that is selected, hit OK. I'm okay with losing the memory, my data in my memory because we're going to keep using this. So now it's got the same data set opened up. It was just from an Excel file. Okay. Anybody still having problems? Yeah.
I still have the administrator problem. I can't.
Did you drop it to your OneDrive?
Yes.
Did you have
If
that?
anyone's fixed it, can someone help me? Can you help me, man?
Yeah, I'll help you out.
Do you know where the settings at? Yes. What type of device do you have? Like what's your Mac? Mac?
I think it's on my Dell, but I can help you out. You just have to click OK.
Please. I would appreciate your help.
This is good. We're actively. So I know how to operate these things through my devices, and it's really hard for me on sometimes things are different for different devices. But hopefully once we get kind of the early kinks kind of all worked out, this should be pretty smoothly. That's why, I don't have any assignments with Stata yet. I want to make sure that we're able to kind of get on, get using it, and then really we'll start diving into how to use it with statistics. Okay. Should get it to work.
Figuring it out.
Okay. I can try to help you after class, play around with a few things as well. We'll kind of look into it. Okay, so we'll keep pushing on here. And this will all be recorded, so you guys can kind of go back and see how we're doing this in class. Yep, so I've got it open again. I'm gonna go back, redo this because I now reopen the data set, right? So the changes I made before, I never saved. So when I rename these variables, oh, they're all capitalized now. Well, that's gonna be real fun. So actually, you guys open it. Some of this code will look a little bit different for you because you did download it as an Excel file just to be able to kind of get through downloading as a, ignoring the CSV. It's going to capitalize things. So that's kind of annoying. So you can do all this same code. You're just going to have to kind of change the variable names so that they're capitalized. I think you should be able to download a CSV from Canvas. But moving forward, I will try to only use Excel files and update all of my do files so that they operate with the names that you would see if you download an Excel file. I think there should be a way you can download a CSV file from Canvas. I'm not sure if there's like a setting that's behind the scenes you have to select, but all right. So let's instead, I'm going to not use the Excel file so that I can actually show you how to run all this code. So let's go import file again. I renamed these variables. So the way this data works is you have this data set open. You can make changes to it, right? Even last class, we talked about, I can do things like generate a variable. Let's work on it after class because it's starting to get a little bit distracting. All right, so we can do things like create a new variable using this generate command. Total tax, which is tax per hash, I believe. And notice here, when I start typing out these variables, it'll sometimes suggest them to me. It's kind of like AI, like it knows what variables exist and it can kind of guess, which one I'm trying to use. And then the other one I had was state tax, right? Yeah.
How do you get the editor up?
The do file editor?
Yeah.
How do you get the do file editor up? How do did I not explain it well? If I didn't, that's fine.
You just go right up to the.
Yeah, so we go back, you open the program up. I said the first two things you would click on are what? The web browser or the data browser. And then your do file editor, right? So you click on this notepad, it opens up the do file editor for you. Yep. And once you have that open, you can open up different do files that I put, you could download this review of statistics one, and you can open that up now through this do file editor, right? So now here, maybe that's where the confusion is. I see. So once I have this do file up, it'll like have a blank one, right? I'll go up here to file, open, and now through here I can find. Oh, that's not. Well, this is one of them, doesn't matter, but I can find different do files that I can open up. Actually, this is catered specifically to this section, so.
Yeah.
Oh, no, I had it in week 2. Right, and then I can open up do files like that, right? I already had it open, so it just spit it back out. But that, you can open up different, you can have multiple do files open if you want to, right? So once you get that editor pulled up, then from the editor, you can start to open up do files. You cannot open up do files from this interface. So if I try to go open here, notice if I try to open this do file, actually, I think, yes, you can. I forgot. It'll just automatically send you if you have the editor pulled up. So you can open do files there as well. It just won't execute those do files for you, right? Yeah.
How do you make it a do file instead of a CSV?
You're not changing the data into a do file. So how do I explain this?
Well, I mean, I have like.
Yeah, so there's 2 very different things. We have the data that is existing behind the scenes. Think about it this way. It's almost like when you're like all the do file editor is here. It's just like Word. You're just typing it. There's no data in your do file. Your do file is just saving code. If you wanted to, you could never use the do file editor. You could type everything into Stata and work with the data that way. The only problem is then it's gone. Once you close the program, it's all gone. So the reason why we use the do file editor is because then I can write all of my code there and I can then execute it, but then I can save it so that when I exit out the program, it just doesn't just go off into the ether. So you're not converting the data, the CSV into a do file. You're okay. But what you can do is you can take that CSV or that Excel file, and after you do some things like rename the variable, or you can create a new variable using that gen command. We talked about that last class. So I can execute this. Well, those changes are made. It created this new variable. But then if I go back, I mean, they're only like currently here. They're not saved anywhere. I haven't saved these changes. So if I want to save the changes I've made to the data, which I did through the code that I was typing in my do file, then I have this option of saving it as what we call this .dta file. So now that I've got my changes, small changes made to this data set, I go up here to File. I'm then going to go down here to Save or Save As. Wait for a second. I've got it here. So state syntax, right? Oops. And notice here, you don't ever want to change this because what we're doing, once we import data, a lot of times it's not going to be in data format. It's going to be as a CSV. It's going to be sometimes like these huge text delimited and all these other, so we can import it. And then really usually what's useful to do, even before we make changes, just save it as a .dta file. So we don't have to worry about importing it all over again. So here I'm going to hit save. It's going to take a second. But now when I go here, and that's where I think I did the two, so I was creating ones for different sections. But notice it's got these .dta files. It's thinking. Okay. Oh, there we go. Now I can actually go, and if I wanted to, just open it up directly. So I have that command in there, but you can always just go to File, Open. Now that I have this data saved as a .dta, now it shows up as a possible file I can open up just straight from Stata. I don't have to worry about importing anything. So now I go to open this, and sure enough, it has those changes I made, that total tax variable, and it changed, it has the variable name changes I made saved as well. Okay. All right. Any questions? Yeah.
When you run, like when you put the commands in and you run it, doesn't it also just save the changes from that?
When I do what?
So they're saying like to save the changes, you have to change it to like a .dta file, but if you.
Oh, so as long as you have it open, it's made the changes in the data that it has open. But if you ever switch data sets or you ever close the program, it didn't save those changes. You have to actually hit save. So for instance, well, we'll make some of it. Let's rename year to be, I don't know, something weird, right? So I'll run that code. If I don't save it, and I go back and I open it back up, once again, you can go to File, Open, and it just puts this use. I already had the path kind of set here, so I can open it back up. Now when I go to the data, still says year. So it makes the change in what you can see, but until you save it, the actual file itself hasn't changed at all. Does that make sense? Yeah.
So you should be saving a do file.
The do file is what you always want to save. That's going to store your code, right? That's where you want it. You don't. So I'm showing you that you can type things down into here. That's not good practice, right? Because that's going to go away, right? You want to type it in your do file and execute so you have it saved there, right? And then you want to save the data as you're making a change. Now, what I would suggest best practices, once again, once I open this up one time, I probably don't want to save it as the same thing because I always want my original data. So if I start making changes and I'm like, I save it, I'm like, oh, shoot, I should have done this differently. Well, now the original data is gone, right? So you probably, if you ever, like once you save, you have this .dta file. If you ever do want to save changes you made, I would call it like state syntax, my changes, or, call it something else so that you can always go back if you make a mistake and start with the original data, okay? These are good questions. This is, you know, how we just kind of get familiarized with kind of using this program, okay? Any other questions before we keep moving? Okay. Are we having time? Okay. So let's go back here. So the original file, I did this for my last class, so we'll get rid of this and I'll kind of add it in and show you. We can also do things. So I'm gonna kind of open that cigarette tax file that we've saved now as a stata file or a .dta file. We can do things like keep or drop some of the data if we're not interested in all of it. So this is where I wouldn't want to then save it because then I'd lose that data forever. But let's say I was just interested in the year 2000, right? I'm going to use this keep command, which says keep the data only if this statement is true. Now, this statement says keep it only if the year is equal to 2000. When we're saying is it equal to something, we're using it's just status language. For that, you have to put two equal signs. It's just the way that the syntax is. Okay. So this, if I run this code, excuse me. Now, if I look at my data, I only have the year 2000 observations, but the other ones are just gone. I mean, they're in the data set that's saved, but the current working data set, I only have the years 2010 left. Okay. So if I then go, oh man, I didn't want to get rid of all those. I wanted to keep more than just 2000. Well, now I can go back, open back up the original file, and I've got the original data set still, or the original data still there. Okay. Some other things that we can do. So let's say I want to go, not keep command. The other one I can use is a drop command. So maybe I only want to keep the years that are greater than 1980 or above. So I want to drop every single year observation if the year was before 1980. Maybe I think something about cigarette tax laws, or something was different in the 70s, and so I don't want to include it in my analysis, right? So we can also use this drop command, and then it just dropped all of the observations. Now I only have the years 1980 and onward. Okay, so these are some little basic things we can start doing using this data. We probably won't use them a ton, but you can start manipulating data sets like this. Okay. So now we can actually look at some statistics and data. Okay. So the very first one, I have the code in here, and this is a good time to point out, sometimes there are shorthand versions of commands. So if I want to summarize a variable, get the mean and the variance, I can go to statistics up here, right, on my stata program, summary tables, summary and descriptive statistics, summary statistics. If I click that, it will then ask me to select a variable. I'm going to do cost per pack. Okay. And it will spit out at me, display to me, the mean, the standard deviation, the minimum, the maximum. Now, these aren't being saved anywhere. It's just output. When it's not technically, it's kind of storing these behind the scenes things in Lake Home, but we're not really going to necessarily use that in this class. But it's really, for the sake of this class, and for all intents and purposes, it's just displaying it to you, right? Doesn't calculate, doesn't save it anywhere, right? But it's nice and useful, right? I mean, there was a lot of observation in this data set. I didn't want to go through by hand and calculate the mean of the standard deviation. Okay. Now, in here, so you'll notice this is the summarize command, right? So once I use the interface, I can always copy, let's say I'm not sure how to code it, but I could find it up here. Well, then once it spits the code out at me, it would be good to then, and I think this was all the lines not in the file that was up on Canvas because I did this for my other section. So I added in this comment, but just copy and paste it into your do file. Once you run it and you know it works, copy and paste it in your do file. Now, I have a little bit of working knowledge of this, so you could also just use the sum command. So here I'm just summing the state tax, and then I'm going to hit execute that. And notice I can get the mean and the standard deviation of that pretty quickly as well. Okay. You can do multiple variables at the same time. So this makes life even easier. You can do like a bunch of the variables in the data set and just summarize them all very quickly. I also want to mention this point because I've been using something and you probably, I'm surprised no one's asked me about it yet. So all this green stuff, right? It's not code. So I try when I'm using these do files, I try to put in comments that help you know what each line of code is doing. And that's also a good practice once you get that first assignment, start to kind of put in comments on your code to what you're doing at each point, right? And also, it also saves you like, once we get to the first assignment, and I'll kind of walk through it in class. Sometimes I'll ask you, like, maybe I ask you, what's the mean? Well, you have the code, but then you also need to know how to find the mean from that stata output. That seems pretty basic. Once we get to some like regression stuff, it's not as obvious like where the statistics are in the output that stata gives you. So you would still have to tell me, like you have the code, but then you also have to tell me what the exact value is, right? So you could just put 2 backslashes and then type out whatever the mean was that stata told you. Those 2 backslashes tells stata, this is just comments. This isn't code that's going to be run. So it'll still throw it up. Like if I run this down here, it still kind of puts it in here, but it's not running any code. It knows that anything past that double backslash, it's just treating as text, not treating it as a code that it needs to execute. Okay. Any other questions up to this point before we keep difficulties we're still having? Okay. Excuse me. You can do the same thing. But if you hit display additional statistics, you can not only get the mean and the standard deviation, but you can get the second, third, fourth moment, variance, skewness, kurtosis. You can even get percentile values from the data set. So this is all very quick, right? This is saving us a lot of time, right? So a lot of what we're doing throughout the semester, it's a lot of it this like black box. It's doing all the math for us behind the scenes. We just need to know how to then take that output and we need to know what it's telling us, right? And how to use it, how to apply it, okay? So that's not too bad. I didn't have this in there. We already talked about this a little bit earlier, but we can create new variables, right? So I think we did this earlier, created this total tax variable. What becomes a little bit more interesting is instead of just this gen command, I mentioned sometimes there's shorthands just to kind of show you that the total command is actually generate, right? But we can always shorthand it by just doing gen, right? So either way, I always just use gen. If it helps you to like know what it's doing by typing out that you're generate, then that's okay as well. Okay. We also have another command that's a little bit different, which is not just gen, but egen. Okay. So what egen does is it basically tells stata there's a bunch of these functions stored behind the scenes, and I want to use one of them. Okay. So egen, and then what new variable do you want to create? Well, I'm going to create this new variable called state tax mean. Okay. I'm then going to call the function from egen, which is mean. So mean tells stata, go through every single observation, add up the state tax value of every single observation, and then divide by the total number of observations in the population. It basically calculates the mean, and then it stores it as this new variable you created. So if I do egen, I'm creating this new state tax mean variable. I want it to be the mean of the state tax. It's created that for me. Notice it's always going to be the same value for every observation because I just calculated the mean of that variable. Okay. Questions on that? It's not too bad. Excuse me. You can do the median, same kind of format. It's just that now we're not using the mean. We're finding the median of state tax, right? And it stores that in there for us. And then we'll go back. We want to calculate the standard deviation. This one, you might not have guessed it. It's just SD. It's not as long of a name, right? So now I can calculate the standard deviation as well and have it saved right here. Okay. Now, I don't know, we'll get there quite today, but we can then, why might I want to do this? Because, and if we don't get there, we'll just kind of hit up on the topic at the beginning of Tuesday. Let me see here. So what I could do here, I now have, actually, I probably did it further down. No, I didn't. Oh, there it is. Yeah, I did standardize a variable. So we talked about, or you talked about in 370, kind of calculating like z-scores, and that told you the number of standard deviations away certain values were. Well, we can essentially do that. We call it sometimes a slightly different thing, which is just I'm standardizing the variable, right? When I'm looking at, for example, this packs per capita variable, I don't know how many packs per capita is a lot or not much, but so it might be more useful to know, well, how many standard deviations away from the average or the mean was that packs per capita usage in that state. So I'll create the mean, right, using that EGEN mean function, EGEN standard deviation. I'm then going to just do some math. I'm going to generate this new packs per capita variable that's standardized. And I'm just going to take the original value, subtract the mean that I now have calculated, divide by the standard deviation, and this new variable should now tell me how many standard deviations away from the mean was that state's packs per capita usage. So I'm going to run all this code. I don't have to run it line by line. I can do all this. And now go over here. So I've got the mean, standard deviation. It's now made all of these essentially representing how many standard deviations away. So this state was 1.76 standard deviations away from the mean. This one was 3.48. Geez, who's that? Kentucky. So right, you go through all of these. Now it's kind of weird here. I did this from another section. I got kind of freaked out. I was like, these shouldn't all be positive. Some of them have to be below the mean just by the way the mean works. It's because all these are 80s. Once you start to get to the later years, people actually smoke less now than they used to. All right. So you'll see here, this was one standard deviation, 1.09 standard deviations below the mean. That state's per capita usage. Okay. So we can do things like that by using these EGEN functions. We can standardize variables pretty quickly. Okay. Any questions on that before you kind of went through it a little bit quicker, but it's pretty, we talked about the other components. Go back to the program and let's see if I can remember where it's at, because I usually just type it in. So if you go under graphics, we talked about this relationship between two variables, right? Correlations, covariances. Well, we can also look at scatter plots, right? So two-way graph. You could then go to create. I want a scatter plot, and I want my X variable to be, what are some interesting ones? Let's do packs per, no. Oh, I got a good one. Let's do tax per pack. And packs per capita as my Y variable, right? So this is going to plot every single observation for the, the values that it had for these two variables. Let's pull this up. Got to be able to hit accept. And then it throws in kind of this plot here. Just have to hit another additional step, which is okay. It's then going to spit out at me. There we go. A nice scatter plot of all the data points, right? So this is kind of interesting in economic, a lot of you are, this is an economics course, so I assume most of you are majors, or at least adjacent. What's kind of interesting here is initially, as I start to tax cigarettes, the usage falls pretty quickly, right? So these are going to be people that probably are just like casual users. Like, I mean, I smoke a cigarette every once in a while when I'm drunk enough, but like, if you told me it was going to be $30 a pack, I'll just stop smoking. I'll never smoke. Not that I won't be drunk enough to ever smoke, right? So initially you might have, these small taxes, people are going to just like that don't really use very often. They're going to stop using quite a bit. But then what happens? Well, now we just keep increasing the tax even more. Who's still smoking? People whose demand is very inelastic. Right? Now we can get this for a nice kind of picture from an actual data set very quickly from the scatter plot. So anyway, I thought that was kind of an interesting example. Another interesting one, I think I have it thrown in here. So it does create this for us. I'm just going to exit out of this and show you. Here I've got the code. So I would just copy, paste that into my do file just so I don't have to kind of always go through those steps. I could just run this code again. I also could just change the variables now. Now that I know the format, instead of packs per capita and the tax, I'm going to look at cost per pack and the state tax. Now, because the cost has the tax built into it, hopefully we get a very strong linear relationship here, which is about what we see, right? Basically, the price is gonna be very strongly, affected by the higher tax, right? It's built in, so. But we can do different scatter plots of different variables. And I think this, I'm trying to highlight, like, once you figure out, you can use kind of the user-friendly interface to find some of these things. But once you run it once, now I know the format of the code and I can just play around with different variables, okay? So I also have, you can use the correlate command to find the correlation coefficient. Once again, if you didn't know that, you can probably kind of play around with, okay, there's some summary statistics. Looks like I want, oh, where is it at? No, I forget where it's at. Summary statistics. Oh, there it is, correlations and covariances. I was looking right through it. You would then just select maybe cost per pack, packs per capita, hit OK. It'll give you like this matrix. Well, obviously cost per pack and cost, it's always the same thing. It's a correlation of 1, right? But here your correlation coefficient between packs per capita and cost per pack is actually negative 0.79. So a pretty strong negative relationship between kind of cost of cigarettes and cigarette usage. So it's not breaking the internet with its finding here. But so we can do correlation coefficients, we can do all these summary statistics, we can do scatter plots. This is just kind of a first glimpse of how do we actually use Stata. Hopefully, once we start to all get it working, start getting more familiarized with it, how do we actually start using it to produce some of these statistics so we don't have to do it all by hand, okay? Where are we at on time? Any other questions for me or anything that I've went through here? Okay. So that should do it for this working state. We'll kind of save this for week 2. So I'm jumping the gun. We already talked about a little bit since I guess downloading the CSV, there's a little bit of issues with it, but we'll start kind of working with an Excel file next class. We'll then kind of do some stuff with conditional means, conditional statements. With that in mind, got a little bit more that I want to go through. So we won't do anything in Stata for this today, but we can just kind of talk through the background of it, and then we'll kind of see next week how we do it in Stata. So we talk about means and we talk about distributions, right? But we also have things what we call conditional means. So this vertical line is saying, okay, look, given that this is true, what's the expected value or what is the mean of this y variable? Right? So the examples that I had, I'm going to have this data set and actually pull out the values. It had all these different math scores, but it also had parental education. Right? So I said, okay, look, I could calculate the mean math score across every single student, but maybe I think there's differences across groups. So I said, okay, given that the parent had 12 years of education, so essentially only use the observations that the parent only has a high school degree. What was the average or the expected value of those students' math scores? It was about 350. Given that they had a college degree, kind of call this like the way it was coded in the data was 16 years of education. What's their math score? And for those, parent students, they scored a little bit higher. Right? So when we're finding these kind of conditional means, we could then say, okay, what is the value of a college degree for the children, right? And, we could say here, it's about 4 points, right? If we take the difference between those two conditional means, we can see, okay, having a college degree, you might expect that on average that the student is scores about 4 points higher on this ISTEP test, okay? You can kind of think about other examples. I think that the dumb one always says like, if I was interested in the average beer consumption of US citizens as an unconditional mean, but then if I said, I'm interested in the average beer consumption of conditional on that the person is currently enrolled in college, probably in a pretty wildly different mean, right? And so anytime we're conditioning on something, it's almost like we're looking at that group's mean. Okay. We'll also use this terminology on kind of references for things later on in the semester. When we say things are independent events, if knowing like conditioning on something, the expected value of the y variable is the exact same as the total mean. So for instance, this would be, I think there's a story that you could probably say this isn't a good example. I think it works. So what if I said, what's the expected value on this standardized math test, given that the parent is 4'9"? It's, I don't know, it's probably the same as if I didn't know that information, right? Those should be independent events, right? Now, like I said, there's probably some story you could tell about being short and doing all that, but it shouldn't have any impact on that child's test score, okay? So if the conditional mean is the same as just the unconditional mean, we would say these are independent events, and they would end up having a correlation of 0. Okay? So we'll use this a little bit later on in the semester. We'll kind of punt on this. This is what I'm going to do in Stata, but we'll kick that off till next week. So I do want to kind of just really quickly go through kind of a couple of things that will set us up so we don't have to waste time with, and it should just be really review. You probably saw the normal distribution in 370. So it's nice, symmetrical, like it folds on top of itself. The mean ends up being the same as the median, is the same as the mode. It's defined really by 2 things. So we'll start thinking about these distributions. I'll sometimes draw them, right? Even if you have the same normal distribution, but it had different means, right? That's just taking that normal distribution and shifting it along the x-axis. The other thing that's going to define it is the variance. So if I had a variance that looked like this, what happens as the variance gets higher and higher? What's going to happen to my normal distribution? It's going to get
Wider.
flatter, wider, however you want to call it, right? It's going to get squished, right? There's going to be more observations further from the mean. So as we have higher and higher variances, we kind of get these flatter and flatter distributions. Lower variances, we get these really nice peaked distributions. Everything's right there around the mean, okay? Just a kind of an example, I had some data laying around and it had like adult males and females, so you can kind of create these different distributions. And, you know, just from looking at distributions of different groups, we can tell things here, right? Male height, the mean appears to be a little bit higher, right? What's also true about male height relative to female height? Yeah, it's flatter, so that means that it has more variation, right? In fact, I don't know, I'm not a biology, like, you know, I took like 1 class in college, but there's something about, like, you look at a lot of different male versus female biometric stuff. Sometimes women's means are higher, so depending on what we're looking at, but almost always male, there's always going to be a higher variance. And there is some biological reason as to why, I just don't remember what it is. So I think, how much time we have? Well, I think we've got just enough time to get through this because it's just going to be kind of reminding you. So we'll start next class to talk about the standard normal distribution. But here, if I ever have a normal distribution and I go 1 standard deviation above and below, there will always be about 68% of the data that falls within 1 standard deviation of that, right? Above or below. If I then go out to 2, well, now I'm already up to 95% of the data is somewhere in between 2 standard deviations of that mean. If I go up to 3, I'm almost 99.7. So are any of you in Kelly? Yeah, so have you ever heard the term 6 sigma? Yeah, what are they kind of getting at? If I go up to 6 sigma, I can guarantee like I'm capturing almost all of it, right? There's nothing left in the tails there. So where do these numbers come from? We'll kind of work on that next class, looking at the standard normal distribution. We'll kind of revisit the Z tables. We won't be using them a ton in this class, but just to kind of remember what they're telling us for stuff that we do later on in the semester. If you're still having some issues with SCADA, I can hang around a little bit. We can try to work them out up here. I might end up sending you to kind of tech people if I can't get it figured out. Other than that, fun, safe weekend. I will see you guys on Tuesday. I'll upload it when I get back to my office. Yep. Yeah. Oh.
Actually, my job
Yes. Yeah, I'll give it in three versions, but, yep.
Okay, so I had it up. Okay.
Yep, so it's gonna be complicated because initially, we're just creating a variable. What the mean is, the mean of the data set should be the same. So then, once you get, so I came down here, this one, I created a new variable. So now I have data that's gonna be different. Does that make sense? Yeah, eGen is just when I want to use one of the built-in instances. So notice generate, I'm typing out the net. eGen is using a stored line of code. Does that make more sense?
Yeah.
Okay.
Going.
So I guess the states is definitely safe this.
You don't really have to worry about saving the data, because as long as you have that original data, you can always go back and rerun it. So really, the main thing you want to always save is that new file. Yep.
Okay, thank you.
So have you, I think that you have. So, here, let me stop this real quick. I'll show you right here.